Let's take a look at a vertical axis wind turbine, a VAWT. Now, I bought one so that you wouldn't have to. This is the unit here, and it's actually made fairly nice, and it has claims to be 600 watts. But we'll see what happens here. So we're going to calculate the available wind power. Okay. So the wind power is going to be equal to 0.5 times the air density times the area that the wind's pushing on times the velocity cubed. Okay. So our air density is going to be 1.225. That's kind of an average kilograms per meter. And then the area is pi r squared. So we take, this is 0.9 meters across, so we take half of that as our radius times pi. It comes out to 0.64. Now, the wind's only pushing on this half here. This half is coming back against the wind, so we take half of that, and it's 0.32. Now, the average wind speed around here is about 11 miles per hour, or 5 meters per second. So we're going with the 5 meters for this one. So we take our 0.5 times our air density times the area times the velocity cubed, and it comes out to 24 watts. Okay, 24.5 watts. Now I'm thinking the efficiency is only about 40%, and the output power is going to be 9.8 watts, not 600 watts, and this is the max you can get out. And so at 12 volts, I'm going to have about 800 milliamps. Okay. Now, the maximum efficiency you can have from a wind turbine was developed by Betz, B-E-T-Z, and it's his law. Says that the maximum efficiency is 59.3%. So what he took the kinetic energy is equal to 1/2 the mass times velocity squared, and your kinetic energy in minus kinetic energy out. Okay, so most efficient when the output velocity is going to be 1/3 of the input. So here's this formula right here. So we take Vn squared minus Vn over 3 squared, and it comes out to 8/9 or 88.88%. Okay. Now, the wind speed at the wind turbine is halfway between the incoming and outgoing wind speeds. If the incoming wind speed is 3/3 is full speed, then the outgoing speed is going to be 1/3. Then the speed at the wind turbine is going to be 2/3. So this is the max you can get out. That's the best case scenario, is to have 1/3 coming out. Okay, so we take our 2/3 times our 88.88%, and that's our 59.3% efficiency. That's our max efficiency. Now, I calculated this one out for you here. Just broke it down. Vn squared, so we take Vn is 1, we square that, that's 1, and Vn over 3 squared, that's 1/3, and 1/3 squared is 1/9. Okay, so 1 minus 1/9, now we take the 1 and make that 9/9, and then we subtract this, so we have 9 minus 1 over, we can combine these two over 9, so that comes out to 8/9 or 88%. Okay, and then we take 2/3 of that to get our 59%. So that's the max efficiency, and I don't think we're getting that. We're going to get, I'm thinking about 40% efficient. Now, there's some other losses, and those are your copper losses coming down. This happens to be a 3-phase generator up here, and for 3-phase, and I calculated it out. I'm using number 10 copper wire coming down, and I'm running about 40 feet. And at 5 amps, that was kind of optimistic. I would lose 2.88%. Okay. Now at 1 amp, I'm not going to lose, probably 1% or something. But you can see if you run a number 16 copper for a long distance, this is only 40 feet, you're going to lose 12%. Now, if you put your DC controller up on top, then you're going to run DC down, and your DC is you get more loss with you running your DC down instead of your 3-phase AC here. 3-phase. Well, you're spreading it over 3 lines here, and only 2 on this side. Now, the charge controller they give you, it converts the 3-phase to DC, and it regulates the charging voltage. It monitors the battery voltage for a 12-volt battery, At approximately 14 volts or so, it switches the turbine from the battery to the dump load, which would be a resistor capable of handling the rated wattage. And in this case, it just shorts out the 3 phases of the generator. And if the wind speed gets up too fast, you don't want it to, get to its maximum RPM and destroy itself. So they just clamp the 3 phases down, and that puts a big load on the generator, and it just slows it down so that it can't run away with itself. So we're going to take a look at this controller. Now, the controller is kind of ingenious the way they did this. This is your bridge rectifier. So you have your 3 diodes here, and the other 3 diodes, they just use the diode that are built into the MOSFETs here, okay? The MOSFET has a diode in here, this bypass diode here. So when they're off, it just has these diodes are in with these diodes here, and it makes your 3-phase bridge rectifier up using the diodes inside the MOSFET. And then when you energize these MOSFETs, what it does, it just takes and shorts all these together, okay? So it shorts these out, and it shorts out the 3 phases here. This phase 1, 2, and 3 on here. So those all get shorted together, and it puts a big load on the unit so that it doesn't run away with itself. So we're going to take a look at that. So here it is here. Here's the unit here. Do we see that? Turn that one on, turn that on. And we got voltage we get there. There we go. So we got 3 volts on there. This is on ohms here, and if we crank up the voltage, if you can see that, 5 volts, 6, 7. We'll see when these should, this side here should short out. Okay, I've just got it tied right to the meter there, and we get up to 10, 11 volts, 13. I said 14, but it probably wants to charge at 14, so we'll see when it actually shuts off. 15, 16, there it goes. So at 16 volts, it shorts out the 3 phases coming down, and that'll stop the blades from spinning too fast up there. So that's kind of a neat way to do that with the using the DC voltage to control the wind speed there, or the blades there with your MOSFETs. And so that's the vertical wind turbine. We can only get about 800 milliamps out of it, not even an amp out of the thing. That's at 5 meters per second. Now at 10 or 15 meters per second, I can get a little bit more, and it takes about 15 meters per second to actually charge the battery. So that happens once or twice a year. So it's not worth it. But anyway, it's interesting to work with the thing, and you always learn something. So thank you.